Okay, well, welcome back to our course. This is Module 3, and for this module, we'll be talking about operating a CNC machine. So let's just review what we're going to be talking about, and then we'll get into some of the details. And so there's several sections. This will be probably broken up into maybe two, depending on how long it goes. I may break it up into three lecture segments. So the first thing we'll be thinking about for the reading and using CNC planning. And so we'll be talking about the setup document. And so basically what we're thinking at this point, we had some ideas of how we, what a CNC machine is, the systems, the controls, and now we're just going to dive right in, start to be thinking about that and how it actually operates. And so that's the first part. Then we'll get into the controller alarms, the operator actions, and monitoring and adjusting. So just as a reminder, quote, the test isn't over. So we can think about, you can pretend like we're all walking into the lab. We're going to start to actually work with some of the CNC equipment. But you've learned enough about the controls to start verifying that the setup was done correctly. So let's just pretend here a friend John is standing at the 65-inch table of the 3-spindle gantry mill. It's the, quote, little one on the side of the shop. So you can see these are big machines set up and ready for the first program. Those 3 pieces of aircraft aluminum are worth thousands before a chip is even made. So you can see that there's a you have to be careful, and that's why we're doing some of this training and helping you to get familiar with it. So he's confident in the setup because the plan was followed exactly. No step or task was skipped, and that would get it right. Many of the skills he used are found in this chapter that we're covering and also a later chapter. So you can think about this. So following the boss's instruction to get the job done ASAP, here in this chapter, it's time to verify the machine setup. Completed on the last shift but not tested yet is ready to go. So you can see how if everybody is following the directions, this should work. You are in John's shoes now. The boss is watching. The skills gained in this chapter will help you prevail in this test of your training. In a future chapter, we'll study CNC codes and commands. We'll learn how to make your own setups and try out the program. Knowing codes will help all of these tasks. And that will be one of the things that we'll be covering later on as we go through this course. So the first section, using the CNC planning, as much as we all tend to try to work before reading the instructions for CNC, make it your first order of business. So just underlining what should be done. Read about any planned work holding tools. Sometimes this isn't the plan. Then general chunks, clamps, or vices are acceptable, but be certain they don't interfere with the program. Verify that the PRZ and any fixed offsets are correct. Find the cutter sizes and tool numbers, then load them into the machine and determine and store tool offset values. Finally, you want to check and see if there are any other special instruction, program halts to measure, or change clamps or reverse the part in the chunk. So the setup document is the one that's going to be guiding you through how you're going to actually do your setup. So the setup sheets are prepared by the programmer. So they are usually prepared from the general planning for the job because they change more often, however, they are part of the planning. So likely, as you guys are preparing for your future career as engineers, you'll be the one that are doing the programming, preparing this setup document. But for the context of what we're thinking about in this course, getting familiar with CNC programming, you can be thinking about being the receptor. They provide the facts needed to set up a job, PRZ location, cutting tools, and the tool path sequences, plus any special instructions such as the mid-program clamping changes, stops to measure, key dimension, and many others. So it's a lot of information. In terms of embedded instructions, special instructions can be supplemented by program commands. These programs can cause special instructions to show on the screen as needed. For example, a clamp change to location 2, measure 1.575 dim per drawing. Those are things that could show up. In terms of cutter selection, when loading cutters, depending on the kind of programming compensation, cutter selection might be, it could be the exact size and shape for programs without cutter compensation. That's less likely in a modern shop. And then second, near to the size and shape listed if the program is compensated for tool differences. So when the program is compensated, you have some freedom to choose tools that aren't exactly the same size as stated in the document. So this is this planning document, but to use this capability, you must tell the control what size the tool you will be using it, stored under the tool radius compensation for mills or nose or radius for lathes. Best practice is to choose tools as close as possible to the stated size. But the very reason for compensation is to be able to use tools that are not exactly as programs. If using insert tools, this isn't an issue unless you change the size or shape. When you use HSS tools that have been resharpened, then the new size can be used to produce perfect parts if the control knows what size they are. Your job is to enter that adjusting offset in tool comp memory. So if some of this isn't familiar, remember you do have a textbook that will help you to go into more details and help you get more familiar with the acronyms that are used. For visiting industry, I find that a few shops choose to always use full-size cutters to avoid any issues with compensation offset entries. They do this knowing full well that the comp allows economical use of undersized cutters, but feel that the savings and offset by the simplicity and time savings are always using new cutters. And so this is a parenthetical reminder for the author and what he has found to be true. So there's two kinds of compensation. So here's the first issue in using tool compensation. Programs are written as cutter path, program path that is the intended tool radius, distance, lathe, or mill away from the geometry. And then you have the part path, a program that has no tool radius built in. The raw path is the definition of the part geometry. So for a trade tip, you must know which kind of path is used since it makes a difference in the amount and value of the tool offset entered in memory. Again, your task to complete is to be thinking about that. For the profile mill cutter path compensation, this profile mill program was written for a specific size cutter, but the size need not be used. Without changing the cutter offset, it traces a line at the center of the listed cutter as it moves around the part geometry, thus its other name, cutter center line program. Using a smaller cutter than that for which the path was written, the offset must be a minus number equal to the difference in actual tool radius and intended. A minus compensation to move the cutter closer to the work by the offset amount. And this is a picture an illustration trying to give us some more insight into what's going on here. So we're seeing a blow up here for a portion of the CNC control panel. When the programming in Mastercam, you will choose comp in computer to create a cutter path program. So remember, if the program is a cutter center line, then the comp is usually a negative number to make the smaller cutter trace closer to the geometry. And for another trade tip, when we are sharpening, cutters become smaller. Therefore, it is most likely that a cutter path program written for a 1/2 inch end mill will use a 0.495 inch real cutter, for example. However, in the very rare case that a cutter bigger than the one found in the document must be used, and the compensation must be positive value to force the path to move away from the geometry. Okay, for path part programs, here the program traces that the shape of the geometry is written with no cutter value in the program, but the programmer has size in mind and listed on the setup sheet. Without a stored radius comp value, you might think of it as a cutter path, but with a cutter of 0 radius. A pencil and the spindle would trace the path profile. As such, all real cutters will require positive offset values equal to the radius to be entered in tool radius comp. The control then moves the cutter off the geometry by its real radius and makes a correct part. And so here is just another illustration of trying to give you a sense of what that is actually referring to. So you want to choose comp and control to create a part program path, and we're seeing this listed here for what that would mean. In terms of how much variation using either kind of program, there are limits as to how much variation the operator has between the intended and actual cutter size or nose radius. The guidelines are spelled out in the text. Lathe cutter nose radius is simpler. It's must be entered in the nose radius compensation. Okay, I'm going to pause there and break this up into smaller bits, and so I'll be right back.